Christopher Everard. I'm going to go to Chris first, and then we'll bring Max on here in a few minutes. And Chris, are you with us again?
Yes, yes, I am. Can you hear me now?
Excellent. Yes, you're coming in. Why don't you tell everybody just kind of the bulk of the information that you'd like to share?
Okay, well, it was, really basically after I spoke to some friends of mine who live in Osaka, which is the second largest city in Japan. They had the earthquake, then they had the tsunami. And basically a wall of water, sometimes it was traveling as fast as 300 miles an hour or even faster. It's basically wiped out the infrastructure of Japan. And the news coverage was extremely sort of comprehensive considering the situations. But then what happened is that there started to be reports of cooling problems at nuclear reactors. And from that moment onwards, which was 4 days ago, the news that we started to get on the BBC in Europe started to become very, very vague. And so I started telephoning my friends in Japan, and also the Enigma channel has lots of viewers and readers of Feed Your Brain magazine in Japan. So I began by calling friends in Osaka. I'm also friends with people like Koji Morimoto, who's one of the world's greatest animators. He invented the Akira anime cartoon TV series and motion pictures. And so I've been calling these people, and the situation, ever since the radiation and cooling problems started, the situation in Japan, as far as the European media is concerned, has not been properly reported. Well, and so I suggested that we do this special broadcast.
I completely agree. We're seeing the same thing with the American media. We've got mixed reports. Some of them are saying that nothing's going on. Others are saying that the radiations is off the charts. What does it come down to?
Okay, well, it's both things are true. Right down in the south of Japan, life is continuing, and the tsunami really devastated the northeastern coastlines. Now, in this broadcast, what I'd like to do is I'd like to just cover some very, very important things which the media are not discussing. First of all, I'd like to just tell people how nuclear reactors work. I'd like to tell people about the different forms of radiation. I'd like to tell them about plutonium, which is a wholly man-made element. I'd like to tell people how to block radiation and what materials block radiation. I'd like to tell people about radiation sickness. I'd like to, talk about Chernobyl, which happened in the Ukraine in 1986, and then I'll really go into Fukushima. Fukushima Prefecture is not one town. My impression of the northeast of Japan when I visited there, the first time I visited there was 20 years ago, is that it was just one giant nature reserve. In actual fact, there's a place north of Fukushima called Hokkaido, and that is famous for its wildlife, for its eagles. There's monkeys, there's kind of boons there, wild deer. It's very beautiful. But in that 20 years, the Japanese population has blossomed. And I was absolutely gobsmacked when I spoke to my friends in Tokyo, and I found out that Fukushima Prefecture is not just one town. There are several mini cities there, and these are the places which were most devastated by the tsunami. So I'd also like to cover in this broadcast the precautions that people should take, because the media is not covering carefully what precautions people can take. And I'd also like to talk about the economics of the situation and, end the broadcast with some solutions for some people. I'm not a fearmongerer. I really don't like the kind of broadcasts that you get where, they read the news feeds and it's all doom and gloom and disaster. What I'm amazed at is that there is absolutely just this vagueness, this unscientific nonsense being peddled out by the European broadcasters. There are people being wheeled onto the BBC wearing pink bow ties, saying this is our nuclear expert. They're not even telling people the most basic information about how these nuclear reactors work and how to just do basic, simple things in your daily life to take precautions against radiation sickness. So can you guys hear me okay?
Yeah, you're coming in
fine.
loud and clear.
Okay, well then what I'd like to do, if that's okay with you, I'd just like to tell people now how nuclear reactors work, just in very, very basic sense, because
Absolutely.
once I tell you this,
Chris,
then you're...
Let me bring on Max Igan, and that way, if he has any points that he wants to make during the conversation, he can just jump right in. Max, thank you very much for joining us.
Thanks for having me on the show, Chris. Nice to talk to you again too, Chris Everard.
Hello, Max. It's great to hear from you.
Yeah, look, the situation in Japan, I believe, is a lot more serious than what people are letting on, a lot more serious than the media is letting on. Just the nature of the reactors even. These are very, very large reactors. They're bigger than Chernobyl. One of the reactors, actually reactor 3, I believe, is powered by a fuel called MOX, which is made from plutonium, depleted uranium. It's a very dirty fuel, but it burns a lot hotter. And so were this plant to melt down, it would be far more damaging than Chernobyl. I believe, and I'm not one to fearmonger, as many people know, whoever listens to my stuff, but I think the situation we're going to see in Japan is possibly even up to 6 meltdowns. And it's a very, very serious situation. I heard you also commenting earlier, Chris, that Europe and places like this are a lot closer to the source of pain than the United States. But unfortunately, we have the jet stream, the North Atlantic jet stream, or the Northern Hemisphere jet stream, which actually travels from west to east around the globe. So what you find is that the localized radiation in Japan will depend on the local prevailing winds. But on a global scale, the radiation that goes into the higher airstreams, this will go from west to east. So the first landfall it will make will actually be the west coast of the United States. It will have to blow right around the world before it actually gets to Europe, because that's the way the jet stream blows. So,
I didn't think about it like that. I was just thinking about Chernobyl.
So it is. This is a very, very dangerous situation. It's a very serious situation. I was actually talking to Lorraine Murray the other day, and she said that of all the places not to build 55 nuclear power plants, the Japan fault line would have to. I mean, you've got a section here where you've got 4 tectonic plates meeting each other. It's the most seismically active area on Earth. And they've built all of these nuclear reactors there. She actually wrote an article, which I've got posted on the Crow House, in 2004 called Japan's Deadly Game of Nuclear Roulette. And in that article, she says it's not a matter of if, but of when there's a nuclear accident in Japan. And this is exactly what we're seeing. I think it's going to end up being a very serious situation. I honestly, as much as I love the Japanese people, I think it's very doubtful that Japan will recover from this accident. I think, like, Japan is an area the size of California. It's not a very big place. And a nuclear accident of this scale, I think, is going to do an awful lot of damage to Japan.
Yeah, I agree. I think this is going to basically create another dead zone. Now, we have already on the face of the planet a dead zone which is 1,100 square miles of complete and utter no-go area, which is in the Ukrainian forest. And that followed the Chernobyl disaster, which happened in 1986. Now, I agree with absolutely everything that Max has said there. What we're dealing with already, and this is according to the Japanese Ministry of Energy, we're dealing with a 1,600 square kilometer area around Fukushima Prefecture, which is already designated as a no-go zone. This is very, very serious. Now, with Chernobyl, the 1,100 square miles of dead zone which we have there now, there are about 3 major towns, including Chernobyl itself. This is very different in Japan because we have actually Sendai, which is a pretty big mini city. We have the Fukushima community itself, and we have about 3 other towns as well. And today I received on the satellite telecast system from Paris footage that was filmed last night, yesterday evening, and it's -2 degrees in the evening. It's snowing. There is immense disruption to the electricity supplies. There's virtually no electricity. People are getting angry because the evacuation centers have already run out of food. This is a fairly densely populated area, much more densely populated than Chernobyl. So I would just like to explain to people the basis of how these reactors work, because once I've described this, it takes me about 5 minutes, people will then realize that this technology is not 21st century super duper high-tech technology. This is actually 19th century French technology that was developed by Madame Curie. She was the pioneer of doing research into radium and uranium, and she actually died. She died of radiation poisoning after experimenting for several years in a laboratory. She won the Nobel Peace Prize, and she's the person that is really responsible for kicking off this nuclear industry. Now, the Earth's crust has natural radioactive rocks, ores, and minerals in it. Now, the primary source which we're seeing being used is an ore, a metallic ore called uranium. And uranium is very, very soft as a metal. It's very heavy, it's very dense, it's rather like gold. And we get uranium in the Earth's crust in Australia, in Canada, and also in Africa. Now, it poses really no threat to humans whatsoever in its natural state. What they're doing is they're dredging out and mining huge amounts of uranium ore. And then what they're doing is that they're using sulfuric acid to dissolve out the nuggets of uranium, and they're then re-solidifying it using centrifuges. And so what they're doing is they're purifying that uranium. Now, once you've purified the uranium and it's sort of smelted into the uranium equivalent of ingots, rather like gold bars, what they discovered is that if you get these just blocks of uranium and you just pile those up in the corner of a room, they will gradually get hotter and hotter and hotter, because what happens is that the uranium has atomic particles that just fling off. They fly off, and they hit and rebound each other, and that is really what irradiation or radiation really is. And the first tests were done at Princeton and at Aldermaston in the United Kingdom, and the first nuclear reactors were really just called piles. And the reason they were called that is because they were literally just piles of uranium bricks. Now, you have to be very, very careful piling this stuff up, because if you pile that uranium up, it will just get hotter and hotter and hotter and hotter.